all measurements are estimates. Okay, all measurements are estimates. So here I have a graduated cylinder, let's say, and I'm measuring the volume of this. Okay, so there are kind of steps. There are steps that you're going to want to take to make a measurement in science. Okay, the first thing that you have to do is you have to figure out the scale of your measuring instrument. Okay, and that's usually just by saying, like, what is the value of the smallest markings? And one way that you could do this is you could go from like 5 to 4, okay, and you do the subtraction there. And let's say that this is in milliliters. I feel bad that I'm not giving my units here. Okay, so I go 1 centimeter. Here, I'll do this. Okay, I go from 4 to 5, so 5 milliliters minus 4 milliliters in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 markings. 10 markings. Okay, which means that my scale, this is 1 over 10, that's 1/10. So that's a tenth of a milliliter, so 0.1 milliliters. So this is how you could figure out the scale mathematically, or you could just look at it and kind of figure it out. Step 2, write everything you know for sure. Write everything you know for sure. Okay, so I know for sure that this meniscus falls between 4 and 5 milliliters. Okay, so, and in fact, I know that it's not above 5, it's between 4 and 5. So I know the 4 for sure. Okay, now I could also say that I know that because I'm going from the bottom of the meniscus, I know that it's between 0.1, 0.2, 0.3, and 0.4. So I know that it's 4.3. Okay? Now, that's where a lot of people get tempted to stop. But that's not the right place to stop. Okay? Because we always have to estimate. You always have to estimate a measurement. So the next thing that you're going to want to do is you're going to want to determine the uncertainty of the measurement. Okay? And the kind of rule of thumb is it's half of the smallest marking okay? Half of the smallest marking. So in this case, my uncertainty is 1/2 of 0.1. So 1/2 of 0.1, which is 0.05. Okay, so that's interesting because you can say you now have to estimate the value to the same digit, same place as the uncertainty. Okay, so if my uncertainty is 0.05 milliliters, that means that I know this value between, like, down to the 0.05 level. I should see variation in the hundredths place. Okay, so I need to estimate this last digit, and so I could maybe say that that's 4.32 or maybe 4.33. Okay, and notice that both of these values fall within my range of uncertainty. Okay, now if I had said something like 4.39, okay, now that's outside of the range of uncertainty. Okay, so that's not a great estimate for the volume. Okay, it needs to be close. All right, so why don't you pause it and take a look at this this one, and see if you can come up with the correct value of this volume. So, step 1, find the smallest markings. Well, the smallest marking is 0.2 milliliters. Step 2, okay, I only know that this is between 6, or I only know the ones value for sure. So that's 6, okay? Now my uncertainty is 0.2 over 2, which is 0.1. So I need to estimate to the 10th place, okay? So I'm going to go ahead and estimate 0.1, okay? So my value then becomes 6.1 milliliters, okay? And that's my answer. So it's important that everybody does their measurements the same way, okay? Because all measurements are estimates. So if Johnny estimates his measurements a different way than Susie estimates her measurements, then we're going to have chaos and pandemonium, okay? So we have to have rules for the way that we report our measurements. And we call all the digits that are reported correctly in a measurement significant figures, okay? They matter. They're significant, okay? So, rules for counting significant figures. All non-zero numbers are significant. They count as significant figures, okay? And I'll often abbreviate these as sig figs or as just SF, all right? So if I have a number like 4.33, okay, none of these values are 0, so they're significant. So how many significant figures do I have in this number? I have 3. Okay, 0 sandwich between non-zero digits. I do enjoy a good 0 sandwich. So for example, 202. 202, the 0 here is significant because it's sandwiched between two non-zero digits, which means it has 3 significant figures. Now, what if I do 2002? Okay, well, these are still sandwiched between non-zero digits, which means that this would be 4 significant figures. Okay, well, hold on. How about if I throw a decimal place in? Does that change things? No, these are still sandwiched between non-zero digits. Decimal place doesn't matter. That's still 4 significant figures. Okay, leading zeros are never, 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 ever, ever, never, never significant. Okay, and let me show you why. You would never write this number. You would never write 25 that way. That'd just be a silly way to write things. Okay? So, you don't. These are totally superfluous zeros. Okay? So this only has 2 significant figures because leading zeros are not significant. Now, what about if I do something like this? Now I've added a decimal place, but all of these zeros are still only placeholding. They're only being placeholders, okay? They don't actually change the value at all. So this is still 2 significant figures, all right? The presence of a decimal place doesn't matter if we're talking about leading zeros, okay? Now, trailing zeros are where things just get weird, okay? Trailing zeros are only significant if the number contains a decimal place, okay? So this number, 200, this has 1 significant figure, Okay? Because these are trailing zeros, these zeros trail the non-zero digit, and there's no decimal place. So if you write a number like this, you're representing that this is your significant figure, your only significant figure. Okay? Now, if I write it like this, now I'm specifically representing something else. This is 3 significant figures, because now I have a decimal point. All right, there's another way that you could represent this, which I don't use much in this class. Other people use it, but I don't use it a lot. And that's to underline that number to show that it's significant. Okay. Sometimes when I'm doing long calculations and like you follow your significant figures through calculations, I'll use this as a way of showing like how many significant figures I have in a certain number. But doing this would still show 3 sig figs. So my question to you is, how can I get this value, show this value 200, with only 2 significant figures? Okay, I want you to pause the video. I want you to think about it. I want you to write something down and yeah, come back. All right, so oftentimes when I ask this question, I'll see people say something like this. Okay, well, this is 20. This is 200. When we're trying to express the number of significant figures, we can't actually change the value. That's just silly, okay? So that's not going to work. Now, really the best way to do this is to use scientific notation. Now, this 0 is a trailing 0, okay? And there's a decimal point, which means it's significant, okay? So this shows the same value, 200, but with 2 significant figures. There are times where you will have to use scientific notation to express a number correctly, okay? So the other way that you could do this is by underlining that value, okay, the tens place, because that would say that these are significant. Okay. Now, one of the things that I wanted to go back and kind of cover is these are, like, we don't do numbers in science that really aren't measurements. Okay, they're either measurements or they're like constants that were calculated from measurements. Okay, so all of these are measurements, which means if I go back and I look, all measurements are estimates. And if I think about what we did on this page here, what that means is that this last digit here, okay, it's significant, but it's an estimate, okay? So you would expect some variation in that value. So each of these I could go through and I could find where the estimate is, okay? So for example, here's the estimate. It's always going to be the significant digits farthest right. Here's the estimate. Here's the estimate, here's the estimate, here's the estimate, here's the estimate. Okay. Now this is where it starts to get interesting. Okay. I have one significant figure. These zeros are just placeholders. They're not actually part of the value. This is an estimate. It's my only digit, which means that this value is really somewhere between 100 and probably 300 reasonably, okay? And in this one, my estimate is here, so that means that I'd be estimating to the in the ones place, okay? Here I'm estimating in the tens place. Now another thing that I want to go back and I want to tie in, okay? Let's go back to here. My smallest marking on this was 1/10 of a milliliter, sorry, 1/10 of a milliliter, which means that the smallest marking usually occur in the digit before the estimate, okay? So that tells you something profound about what was used to measure this, all right? So this, the smallest marking on this was maybe in this digit. So maybe it was 0.1 of a gram, or 0.1 of a milliliter, or 0.1 of a centimeter, okay? So let's go back down to the weird case. That means that this, the smallest marking, was in the next digit up, which is probably the thousands, which means that this was probably a beaker that went like 0, 1,000, okay? And the water level's somewhere in here, all right? Which means it's hard to tell like what that is at all. Here, this meant that the smallest marking was tens, okay? Which means that you have a lot more certainty about this value than you do about this value, okay? All right, so let's go through, and I want you to pause the video. I want you to look at all these, and I want you to count the number of sig figs, and I want you to tell me how many sig figs are in each number and why, okay? What I'm really looking at is, are these digits significant? Are they not, and why? Okay? So this first number has a couple different types of digits, all right? So I've got all these zeros here. These are all leading zeros. And leading zeros are never significant, okay? So really what I'm looking at is these 4 digits, okay? So I've got 3 non-zero digits, and I've got this 0, okay? And the 0 is sandwiched, okay? And the sandwiched 0 is always significant. So this has 4 significant figures, okay? Well, what about this number? So this number now has, this 0 is a trailing 0. Okay? Trailing zeros are only significant if there is a decimal point. So that's 1, 2, 3, 4, 5 significant figures. Okay? Now, hopefully you're kind of catching on to the dialogue. I mean, it's a monologue because I'm by myself, but I'm having I'm thinking out loud. One of the skills that you need to pick up is to make your thoughts verbal, okay? Think out loud a little bit. Sometimes you need to talk to yourself. People might think you're crazy. That's okay, all right? Nobody wants to be normal. Normal is weird. Be crazy. Talk to yourself. Think out loud. Be awesome. All right, I'm done. How about 3? Well, these are leading zeros, and they very clearly don't belong here. So, yuck, blech, bad. Just 2 sig figs, okay? Because leading zeros are not significant. All right, how about this one? Well, this has 3 significant figures. Because this 0 is a trailing 0, but there is a decimal place. So it's a trailing 0 with a decimal place, so that is significant. Okay? Now, a lot of people get a little confused by the scientific notation. Well, what about this 10? Well, keep in mind that this is just a placeholder. This is really just 1.40 times 10 times 10 times 10, okay? All this stuff is doing is telling you like what order of magnitude you're in, okay? Those aren't important. They don't add to your measurement or anything. They just tell you how big or small your number is, all right? They don't count for significant figures. It's only the coefficient or mantissa. All right, so rounding off significant figures. Okay, now your book has this sort of like confusing procedure for rounding significant figures, which is probably more accurate. Well, it's more scientifically rigorous, all right? And if you think about it, it makes sense. But that's not what we're going to do here, okay? I'm just going to simplify. And the way that I'm going to simplify is, if the digit after the last significant figure is less than 5, round down. If the number is greater than 5, round up. Okay? So this value with 2 sig figs, meaning I need to cut off here at this 3, okay? 5 is greater or equal to, oh yeah, this should really be greater or equal than 5. Okay, so with 2 sig figs, this is just going to become 2.4. Okay, now with this one, okay, I want to round to this number. Now, a lot of people have the tendency to think, okay, well this number is 4, but this number is 9. So if I round, this will round up to 5, and then that'll round up, and they have a tendency to say 2.36. No, you only look at this number, okay? So this is 2.35. Rounds down. It's less than 5, okay? So that's counting significant figures and rounding significant figures.